Welcome to 3 Inquisitive Kids. This is Karen with another solution to the same problem from the previous video. Here is the problem again. Find the shortest distance between the origin point and the y is equal to 6 over x graph. So we start by just drawing out a point on this line, and we set it at the coordinates x comma y, x as its x coordinate and y as its y coordinate. We also connected it with the origin point with line D. D is the length that the shortest distance is between this point and the origin point. We just don't know what it is. And D is what we're trying to solve for throughout the problem. So let's first write what we know and the information that we are given into a system of equations. From the problem, we know that y is equal to 6 over x. So we already have a relationship between two variables. But here we see that if we draw auxiliary lines from this point down to the x-axis, we can create a 90-degree angle, which is creating a right triangle. And the formula that is most famous for right triangles is, of course, the Pythagorean theorem. We know that x squared plus y squared, x and y being the two legs of the right triangle, is equal to the hypotenuse squared, which in this case is d. So x squared plus y squared is equal to d squared. These two equations will make up our system of equations. We're trying to solve for d. We can set the first equation as number 1 and the second equation as number 2. What I'd first do is modify equation number 1. By multiplying x onto both sides of the equation, we get xy is equal to 6. Okay, now that we have the value of xy, and we look at the second equation, there's x squared and y squared. Seeing two squares reminds me of the power formula, which is a squared plus 2ab plus b squared is equal to the square of the sum of a and b. Now let's try to see if we can apply this formula anywhere. Well, first we have to add 2ab or negative 2ab onto the second equation. We can do that by subtracting 2xy onto both sides. So we have x squared minus 2xy plus y squared. And you might be saying, Karen, you can't just add stuff to equations. Well, the value will still be the same as long as we do the same to the other side. So on the other side, we have d squared minus 2xy. But remember, we already know the value of xy because in the first equation, it says xy is equal to 6. So really on the right side, we have d squared minus 12. And on the right side, we have x minus y squared. Now here is when it gets interesting. Remember that since this is a square, it must be greater than or equal to 0. So d squared minus 12 is greater than or equal to 0. Remember, we know this because d squared minus 12 is equal to a square. So that itself must also be greater than or equal to 0. From that, we can solve for inequalities. And by adding 12 onto both sides, we have d squared is greater than or equal to 12. Then we can take the square root of both sides, which gives us d is greater than or equal to the square root of 12. So d is greater than or equal to the square root of 12. Now let's go back to the problem and see how we can solve how we can answer the actual question. Find the shortest distance between the origin point and the graph. We have set, remember, d represents the shortest distance, and since it must be the shortest, what is the smallest possible value for d? That would be the square root of 12. So the shortest possible distance would be the square root of 12. Thank you so much for watching 3 Inquisitive Kids. Remember, we love interacting with you guys, and thinking about what you guys think of these problems. So if you have a different solution that we haven't covered yet, please feel free to put it in the comments down below, and we're really excited to see what you have to say about this problem. Again, thank you for watching, and we'll see you next time.